Alright, so here we're going to do 1939, okay? And we're just going to start with A for now and say, how would I synthesize compound A from benzaldehyde? So this is benzaldehyde, and I'm looking to make this molecule. Okay, this is not particularly easy to do at all, okay? Because effectively what I need to do is add one carbon. And there are not that many ways that I can add one carbon, but since we're in the chapter of carbonyl chemistry, it's worth noting that we can add one carbon, or one carbon synthon is what we call those, by adding formaldehyde to a Grignard reagent, okay? And that was something that we've seen in a number of cases. We don't have, if we do add formaldehyde to a Grignard reagent, what that gives us always is a primary alcohol. Okay, we don't have a primary alcohol here, but what we can start by envisioning, again, if I identify that I'm adding one carbon, that's step one. Step two is saying, what are the ways I know to add single carbons, and one of them is by formaldehyde addition. And I can say that knowing that formaldehyde addition gives me an alcohol, I now have to say that even if I don't have an alcohol here, I can envision that this guy came from this primary alcohol, okay, and that this primary alcohol product could have arisen from now a Grignard addition of benzyl Grignard over here plus formaldehyde. I can always check in the forward direction, see that this would in fact give me a primary alcohol, and that this primary alcohol, if I oxidize it carefully with DMP, will give me this aldehyde. Now the question becomes, how could I have formed this kind of Grignard from benzaldehyde? Well, this Grignard could have come from this benzyl bromide by adding magnesium metal. Now effectively we've simplified this problem to say, how do I make this benzyl bromide from the reduction, or from benzaldehyde? Okay, and that's really a two-step process. In the first step here, what I say is that this guy could have come from benzyl bromide could have come from the alcohol, alright, and that alcohol could have come from benzaldehyde. In the forward direction, starting with benzaldehyde, I reduce it with sodium borohydride to form this OH. I can convert this primary OH to a primary bromide by treatment with PBr3. I can now convert that to a Grignard reagent by adding magnesium and ether. From there, if I add formaldehyde, it gives me this alcohol, and then DMP gives me the desired product. So this is a lot of steps in our head now. Again, to look at this and say, 1, this is a 1 carbon addition. 2, I can do 1 carbon additions by formaldehydes. 3, formaldehyde products are alcohols, the addition of Grignards to formaldehydes. Alright? 4, alcohols can get oxidized to carbonyls. 5, how do I generate a Grignard? From benzaldehyde in theory, and going through all of these steps to get back to benzaldehyde, and then putting it all together in this kind of forward reaction pathway. I'm going to do the next one here, which asks, hold on, let's see if we can find that easily enough. Can I do this compound? Can I take, let's see, benzaldehyde and form this enamine, okay? So here what we're doing effectively is we're adding 1 carbon, and we're also forming an enamine. This enamine could easily have arisen from the addition of this secondary amine to acetophenone, so this ketone over here. And this ketone in turn could have come from the oxidation of a secondary alcohol. Alright, now the question now becomes, how could I form this secondary alcohol from benzaldehyde? Well, that hopefully is more straightforward, because I know that if I take an aldehyde and I treat it with a Grignard reagent, I will form a secondary alcohol. So again, I can put that all together now, and in the forward direction say, starting with my benzaldehyde, I add methyl Grignard plus acid in the second step. I get this product. I can oxidize that to the ketone, and then I can do enamine addition to secondary amine addition to this ketone under acid catalysis to generate the desired enamine. Alright, so that's B here. C asks us, where is C? I want to form this compound here, this alkene, from a Wittig reaction, from benzaldehyde, and that's pretty much clearly a Wittig reaction. I can take this alkene, break it down the middle, simplify it to carbonyl plus Wittig reagent. I can try to do it in the other direction. What I mean by that is putting the carbonyl on this side of the molecule and the Wittig reagent here, although that's going to give me now a secondary bromide that will not be amenable to nucleophilic attack, so that's why I'm better off breaking the compounds apart this way. When I break them apart this way, I can now say that this ylid, this Wittig reagent, came from an alkyl bromide, okay? And this bromide now could have arisen in turn from the benzaldehyde, okay? In the forward direction, what that means is I take benzaldehyde, reduce it to the alcohol, PBr3 brominate, use this to make the Wittig reagent, and then treat that with cyclopentanone to give me now the desired final product. Alright, so that's now, I think, going to conclude now 1939 and solving that problem. So what I'm going to do now is 1941 B and C, okay? So 1941 asks, hold on, let's find that, guys, hold on. 1941, the question is, how would you make these compounds from cyclohexanone? Okay, so if I start with cyclohexanone, I want to add this compound. And the question really is, how am I going to do that? How am I going to get functionality at that carbon? And the key, I think, to recognize is that if I need to functionalize this carbon, that is one carbon removed from the carbonyl, what I really need to do is figure out how I can use this carbonyl to get functionality here. And for our purposes, being able to functionalize an adjacent carbon like that pretty much means that we're going to have to figure out how to turn this carbonyl here into an alkene. And there's no way that I know of that I can take a carbonyl and go straight to alkene. But I know that what I can do is do a carbonyl to form an alcohol, that alcohol can give me an alkene, and that once I get the alkene, I can figure out a way to get, again, functionality specifically here, okay? So this ketone, okay, this guy here could have come from an alcohol, the oxidation of a secondary alcohol, which could have come from this alkene. This alkene, in turn, could have come from dehydrating this alcohol, which could have come from cyclohexanone. So let's try to do this in the forward direction. If I take cyclohexanone, I know I can add a benzene ring by using Grignard addition, so phenyl magnesium bromide followed by H3O+. I can dehydrate this to give me an alkene, and this is a way, again, to sort of translate the functionality that starts at this carbon into something where I can functionalize over here. If I do this alkene here, I then treat this with hydroboration oxidation. That gives me an OH selectively at the less hindered side. Okay, so I'm starting with an OH at this carbon, form the alkene, selectively put an OH back, but do it at a different carbon. Now I can do oxidation of the secondary OH to give me my desired product. But the key in this problem is to identify, again, that I need to figure out a way to functionalize at a adjacent carbon, and for our purposes that pretty much means alkene. Now if I look at this cyclohexanone, this is part C, I look at cyclohexanone here and I say I want to make this compound. This pretty much screams OSO4 dihydroxylation of an alkene, which now makes this a relatively simple problem, okay? This guy has to come from cyclohexene, and cyclohexene itself, again, can't come directly from cyclohexanone because I can't go ketone to alkene or alkene to ketone, but I can always do ketone to alcohol to alkene, and also the reverse, alkene to alcohol to ketone. So now in the forward direction, sodium borohydride reaction on this cyclohexanone gives me the alcohol. I can dehydrate that. This is good reagents for dehydration of secondary alcohols to get this compound here, and then OSO4 dihydroxylation followed by this NaHSO3 to break apart that intermediate osmium ring system now gives me this OSO4 product over here in this case. So I'm not doing all of them for this problem, but I think this is probably enough to get the idea of what's going on.